All right, you guys, today we're going to talk about properties of exponents. This will look kind of familiar. You did do it back in Algebra 1, so it might look familiar as we do it, but we'll do kind of a refresh on it. All right, just a refresher on some of the definitions or some vocabulary. Remember, if you ever hear us say base, the base is the number that is being raised to the exponent. So in this case, 2 to the third, 2 is our base, and 3 is our exponent. So also, just a reminder, remember, 2 to the third would just mean 2 times 2 times 2. So 2 is our base, and 3 is the number of times we're multiplying it by itself. Now, the product of powers, if we're multiplying 2 of the same base, we add the exponents. Why is that the case? Well, if I did 2 to the third times 2 to the fourth, sometimes if we write it out, it sometimes helps. So 2 to the third would be 3 2's. 2 to the fourth would be 4 2's. Okay. So how many 2's total do we have? Well, it would be 2 to the seventh, which 2 to the seventh is 128. So 2 to the third times 2 to the fourth would be 2 to the seventh, which is 128. So if I look at some more examples, if I had x to the fourth times x to the fifth, well, if we think about this, this is 4x's, okay, times 5 more x's. So how many x's do we have? It would be x to the ninth. Okay. Now we can do the same thing even if it's not just one variable. We just kind of take it like by parts. So first we multiply our numbers. So 5 times 7, which is 35. Okay. Then I have x to the third, so I have 3 x's. And then I have 7 x's. Okay, so we have 7 plus 3 would be 10, so this would be x to the 10th. Okay, and then we have 4y's plus 11y, so this is going to be y to the 15th, and that would be our answer. Okay, so every time we are multiplying, we add our exponents, and notice though we will multiply our numbers. So when it was just 5 and 7, we multiplied those, but we added our exponents. Okay, when it's division, okay, we subtract our exponents. I like to think of this more of like crossing them out though, because we already kind of did that. So if I have 5 to the seventh divided by 5 to the third, really what we're doing is we're taking away 5 3's on the bottom, or sorry, 3 5's on the bottom for 3 5's on top, which would be left with 5 to the fourth, which 5 to the fourth would be 625. Okay. Or if we say, okay, 7 minus 3, that would be 4, so 5 to the fourth. Now, you just have to be careful when you subtract because you might get a negative, and we'll talk about what negative exponents do. I think it's sometimes easier just to cross off matching terms on top and bottom. So let's take a look at some examples. So I have m to the seventh over m squared. Well, we can take away 2 m's down here for 2 m's up top, so I have m to the fifth. Okay, that's going to be on top, and then we just have nothing left on the bottom, or just 1, so we can put a 1, or we can just say that that's m to the fifth. Okay. Now let's look at this next example where we have kind of multiple terms there, or multiple parts. We have numbers, and then 2 types of exponents. So let's just look at our numbers first. So I have 4 and 8. Well, we can simplify those to 1 and 4, or sorry, 1 and 2, because we divide both of those by 4. Okay. Now if we look at our x's, I can take away 1x there for 1x there, so I'd be left with x to the fourth. Okay, and then our y's, we can take away 6y's on top for 6 on the bottom, so this would be y to the fourth. Okay, now be careful, if I did 6 minus 10, that would be negative 4, but now notice that this 4 is actually on the bottom, or this y to the fourth is on the bottom. And we'll talk about what negative exponents do in a second, but that's why I like to just cross off and then just rewrite what we have left. So this is going to be x to the fourth over 2y to the fourth. Now if we ever have a power to a power, so if we notice we have x to the a power to the b power, we multiply our exponents. And why is that the case? Well, if I did 3 squared cubed, well, I would write 3 squared 3 times. Okay? And then remember, that just means 2 3's, 2 3's, 2 3's. So how many 3's do we have? Well, 3 to the sixth, which 3 to the sixth would actually give us 729. Okay, but what we do, if we do 2 times 3 gives us 6. So that's kind of the shortcut, is that we can multiply if it's a power to a power. So let's take a look at an example. Now, I have y to the 4th to the 3rd. So remember, that means y to the 4th, y to the 4th, y to the 4th. Then if you need to write it out even further, you can. This is just to kind of visually help us. You don't have to write it out, but sometimes if you're in doubt, it helps to write it out. Look at that, that rhymed. But if we do that, that'd be 4, 8, 12, or 4 times 3, which is 12. So this is y to the 12th. Okay. Now for this next one, you got to be careful. This power is going to go to all 3 of these, right? So this is going to be 2 cubed. Well, 2 cubed is 8. Okay. Now this is x cubed cubed, so we can multiply those. So it'd be x to the 9th, or sorry, x to the 9th. And then this is going to be y to the 5th to the 3rd power. So that'd be y to the 15th. Since it's a power to power, we multiply, and there's our answer. So the biggest mistake that people make there is they do 2 cubed and just do 2 times 3. No, it's 2 cubed would be 2 times 2 times 2, which is 8. Okay. All right, on this next one, 3 squared, which is 9. Then we have a to the 6th squared, which would be a to the 12th. Then we have c squared, which would just be c squared. Okay. And then on the bottom, it would be b to the 5th squared, which would be b to the 10th. So since all of it is being squared, I have to square all 4 of those. The number, the a, the c, and the b. Okay, and there's our answer. Okay, we'll talk about negative exponents. Negative exponents mean that we are going to have to do the reciprocal, which means we are going to flip it and change the exponent to a positive. Okay, so if we kind of think about it, if I did x squared divided by x to the 5th, well, we could subtract those, right? So 2 minus 5 is x to the negative 3rd. Well, if we think about it, if we look at it up here, I can take away 2 x's for 2 x's. So I'm left with 3 x's on the bottom, so that's why it's 1 over x to the 3rd. Well, this x to the negative 3rd would equal 1 over x to the 3rd. So negative exponents, we flip it and then change it to a positive exponent. So that is kind of what you would probably want to write down. So if we take a look at some examples like this first one, I notice this has a negative exponent. So what I'm going to do is I'm going to take whatever has the negative exponent, I'm going to flip it. So this is going to be 2, b cubed is going to stay on top. But since that a has a negative exponent, I'm going to move it to the bottom of the fraction. So I'll make a fraction, or I'll just put it on the bottom now. It'll be a to the positive 4th. Okay, so negative exponents, flip it, and then change the sign to a positive. So that would be my answer. Okay, now if I look at this one, this next one, I have a to the negative 3rd, so I can flip it or move it to the bottom. Okay, now the 3 out front is going to stay the same since it didn't have a negative exponent, but I'm going to bring that a to the 3rd to the bottom, and now I notice right here that I have a times a to the 3rd, so that's really going to be 3 over, well, a times a to the 3rd would just be a to the 4th. Okay, so that would be my answer. Okay. Now if I look at this one, I notice that this negative exponent, okay, is going to go to all 3 of those. Now there's kind of a couple different things that we can do here. One thing, if you want, you could flip it right away and just say, okay, I'm going to go 1 over 5a squared b to the negative 3rd, and then square it all. Okay. So that would give us 1 over 5 squared is 25. Since it's a power to a power, we would go a to the 4th, and then it would be b to the negative 6th. Now I notice that this b has a negative exponent, so I have to flip that b. So this is going to be b to the positive 6th over 25 a to the 4th. Okay? And that would be our answer. Now, another thing that you could do is you could give that exponent to everything right away and say, okay, this is going to be 5 to the negative 2 power, a to the negative 4 power, and then b to the positive 6 power. And then we would have to flip these two and make them positive, which would give us the same thing. It would be b to the 6th over 5 squared would be 25. And this would be a to the positive 4th. So we still get the same answer, just two different ways that you could technically go about these. And these ones, as long as you're using the properties correctly, there's sometimes a couple different ways that you could go about doing it. All right, the big easy one that we can't mess up, it sometimes is tricky, but anything to the 0 power, anything to raise to the 0 power is 1. Okay? Why that is, well, if I have x to the 4th divided by x to the 4th, well, 4 minus 4 is 0. So anything to the 0 power is 1. So let's take a look. 5 to the 0 power, it's 1. Okay? This whole thing is to the 0 power, so the whole thing would just be 1. So anything to the 0 power is 1. So kind of putting it all together, I noticed right away that this is multiplication, but before I do that, I'm going to go ahead and distribute that exponent to all three of these. So 3 cubed would be 3 times 3 times 3 would be 27. Okay. M squared cubed would be m to the 6th. This would be n to the negative 12 times negative 2 m to the 5th n to the 6th. Okay. I like to, if I see negative exponents right away, I like to just flip them so I don't have to deal with them. So this is going to be 27 m to the 6th over n to the 12th times negative 2 m to the 5th n to the 6th. Now remember, that negative 2 is not an exponent, so you don't flip it. Okay? And if you need to, you can put that over 1, but this just becomes the problem that we did last unit where we can just kind of simplify, right? We have these n's, we can take away 6 on top for 6 on the bottom, so that's going to be n to the 6th. And now let's just write what we have left. Well, negative 2 times negative 27 is going to give us negative 54. And I have 6 m's on top times 5 n's, so that's going to be m to the 11th. We're going to add all over, that's an 11, not a 2. Okay. And then all over n to the 6th. Okay. There might have been another way that you could go about doing that, but that's the way that I did. So if you got the same answer, good job. Okay, so for this one, I noticed that I have that negative 3 power, so it's a negative exponent, so I can flip it right away. Now, you could cube them all right away, but before I do that, I noticed that I can simplify some things, so I'm going to do that first. I can simplify this 2 and this 4, so that'd be 1 and 2. I can take away 4 a's here for 4 a's there, so this is just going to be a. Take away 3 b's there for 3 b's there, so this is going to be b to the 3rd. Okay, so this is going to be 1a, or just a, over 2b cubed. All of that still to the 3rd power. So then now it makes it a little bit easier for us to simplify. Now I just cube everything. So a cubed, 2 cubed is 8, and then b cubed would be b to the 9th. B to the 9th. My pen wasn't working right there. All right, that's going to be our answer right there.